Welcome back. Remember to have your periodic table, and let's go on with ionic compounds nomenclature. We now need to name and write formulas for ionic compounds with multivalent cations. Remember that these cations come from our metallic transition elements in the D block of the periodic table. Metals in groups 14 and 15 also form multivalent cations. Also remember that we use a Roman numeral to indicate the charge on those cations. By this time in your high school adventure, you should know Roman numerals, and if not, make sure that you do. They are all written here for you from 1 to 8. All the rules that we used previously for ionic compounds still apply. We will just add a few steps. How do we write formulas for ionic compounds with multivalent cations? First, we write each ion, and remember that the cation charge is in parentheses. So for lead-2 oxide, lead-2 is Pb with a charge of +2. Oxide comes from oxygen, so we have O with a charge of -2. Now we balance the charges. We have a +2, which balances out a -2. So my final formula is just PbO, because for each one lead ion, I need one oxide ion. For tin 4 nitrite, tin is Sn with a charge of +4. Nitrite is NO2 with a charge of -1. Now to balance the charges, we have to multiply our -1 on the nitrite side by 4 to get a total of -4. Now our charges balance. For each one tin ion, I'm going to need 4 nitrite ions. So NO2, remember we put our polyatomic ion in a parentheses, and then I have the 4. Let's practice a couple more. Titanium 3 sulfide. So that titanium is Pi with a charge of +3. Sulfide is S with a charge of -2. To balance the charges, I have to multiply the titanium by 2. So +3 times 2 gives me a total of 6. And I'll multiply the sulfide by 3 because -2 times 3 gives me a total of -6. Now my charges balance. So for every 2 titaniums, I have 3 sulfides. Copper 1 sulfate, notice that even when the charge is 1, we do have to put the Roman numeral 1. So copper 1 is Cu with a charge of +1. Sulfate is SO4 with a charge of -2. Now I balance my charges. So I have to multiply the copper side by 2 to get a total of +2 in order to balance out my -2 on the sulfate side. So my final formula is Cu2SO. Name ionic compounds with multivalent cations. You will have to work backwards from the formula using the charge of the anion to find the charge of the multivalent cation. In our first example, we have COCl2. We always know the charge on the anion. We know that chlorine has a charge of -1, and since I have 2 chloride ions, I multiply that by 2 to determine the total charge on my anion side. So that's a total of -2. To balance that out, the charge on the cobalt side had to be +2. And since I only have 1 cobalt ion here, my final name is cobalt, Roman numeral 2, and chloride. Let's do the next one. Again, I know the charge on phosphate. Phosphate has a charge of -3. I have 2 phosphate ions, so I'll multiply that by 2 to determine the total charge, and that will be -6 on the anion side. So the charge on the tin side has to be +6 to balance that out. But this time I have 3 tin ions on the cation side, So each tin has to have plus 6 divided by 3, which gives me a charge of 2 for each tin ion. So my final name is tin 2-phosphate. Let's do a couple more examples. PbCO3 again, I know the charge on carbonate to be -2. I have 2 carbonates, so times 2, which gives me a total of -4 on the carbonate side. Therefore, on the lead side, I have to have a charge of +4. There is only one lead, so I have lead 4 carbonate. V3PO4, I know the charge on phosphate to be -3. I only have one phosphate, so the total on my phosphate side is -3. On the vanadium side, I will have a total of +3. Again, I have 3 vanadiums, so I have to divide that by 3 to know the charge on each vanadium. So my final name will be vanadium 1-phosphate. The last one is Fe2O3. I know the charge on oxygen to be -2, and I'll multiply that by 3 because I have 3 oxides. So that gives me a -6 on the oxide side. The total on the iron side has to be +6. I have 2 ions over here, so I divide that by 2 to give me iron 3 oxide. Hydrated ionic compounds, or hydrates, have a specific number of water molecules in their chemical formulas. When these compounds are in the solid form, the water molecules are a part of that crystal structure in those ionic compounds. And when no water is bound to an ionic crystal, the ionic compound is said to be anhydrous. So in the pictures, we have anhydrous copper-2 chloride, which is a brown crystal solid. But when we have the hydrate, which is copper-2 chloride dot 2H2O, it becomes a blue crystal solid. You can see that they look quite different, but they will behave in the same way when dissolved in water. Please note that the dot here does not mean multiply. When we write formulas for hydrates, we use the same ionic naming rules we've been using, and we have to add the number of water molecules. Let's do an example to illustrate this. We have silver nitrite trihydrate. So silver is Ag, and it has a charge of +1. And nitrite is NO2 with a charge of -1. So the charges balance, and my formula for the ionic compound piece is just Ag and O2. You have to memorize this table here and the prefixes that represent the number of water molecules. So mono is 1, di is 2, tri is 3, and so on. So please look at the table and make sure you memorize all of the prefixes up to 10. So when we have trihydrate, tri is 3. So we put a dot with 3H2O. Again, the dot does not mean multiply. Let's practice a couple more. Gold 3 chloride tetrahydrate. Gold is Au. Roman numeral 3 means it has a charge of +3. Chloride is Cl with a charge of -1. So we balance the charges, and we will need to multiply the chloride times 3 to balance the 3+ on the gold. So my formula for the ionic part is AuCl3. Now I have tetrahydrate this time. Tetra is 4. So dot 4H2O. Calcium carbonate monohydrate. Calcium is Ca with a charge of 2 plus. Carbonate is CO3 with a -2 charge. So the charges balance, and we have CaCO3 for the formula. Now we have monohydrates, so dot H2O. Note here that the 1 is assumed, so I did not put dot 1 H2O. On the other hand, when you have one water molecule bound to the anionic crystal, you have to write the word mono. Let's look at how to write the name from the formula. We have MgSO4.7H2O. So we write the name like we would for the ionic piece. Mg is magnesium. SO4 is sulfate. And then dot 7H2O, so 7 is hepta. So I say heptahydrate. We have SnO2 dot 5H2O. Sn is tin. Tin is multivalent, so I have to figure out the Roman numeral. So I look at my oxide. Oxide has a charge of -2, and since I have 2 oxides, I multiply by 2 for a total of -4 on the oxide side. Then the tin has to have a charge of +4, and since I have only one tin ion, I will have tin 4 oxide. Dot 5H2O, 5 is penta, so we have pentahydrate. And the last one, NiC2H3O2.4H2O. Again, I look at my anion, which is acetate. It has a charge of -1, and I have 2 acetates, so times 2 for the total charge, so -2 on the anion side. Then I have nickel for my cation. So on the nickel side, I will have a charge of +2. And since I have only one nickel, we will write nickel 2 acetate. I have dot 4H2O. So 4 is tetra. So tetrahydrate. This concludes our ionic nomenclature. I hope you have taken good notes. See you in class.